Hello everyone, so welcome to a new video. So in this video we'll see how we can uh, configure an AC800M PLC to give a start command and a controller ACS880 Drive. So this is the setup that I have. So I have an AC800M PLC and I have a profibus adapter master module CA854A. So we'll see how we can program this PLC, and the basic startup for doing this configuration I have explained in my previous video. So in this video we'll see how we can connect the drive using a profibus. So this is the PLC side. I have connected the profibus cable here, and in the drive side, so this is my drive, ACS880 Drive. Sorry, not this one. Yeah, so this is the drive. So as you can see, I have a profinet module here in slot 1 and profibus module here in slot 2. So we'll use this slot 2 profibus FPBA profibus adapter to connect the profibus cable from the drive. So the other side, as I said, it is connected to the PLC. So now let's see the drive side first. So in the drive, the field bus adapter setting. So the I have covered this complete explanation for this parameters in my previous video. You can check that if you require. So in this video I'll be explaining only the communication part. So the FPBA enabled. So as I said, it is in slot 2, the profibus adapter. So I defined in slot 2, and in the FPBA settings I gave the node address as 3. This is my profibus address, okay, and I'm going to use PPO2. So this is basically the you can configure as you like PPO2 because I'm reading only it depends on how many data you want to read from the drive, okay. So I'm defining PPO2 here for the transfer of data and to give the start command. And this is the in, means the data that I'm going to send from drive to PLC. So my data in 1 is status word, and data 2 is speed feedback. So this is basically, even if I don't set this, it means status word and speed feedback. The first two words should be always, the first one should be status word, the second one should be the speed feedback, and from third onwards you can define whatever you like. So I had defined DC bus voltage 1.11, okay. So always remember, you need to put it into 16-bit because we are going to use a 16-bit data type, okay. So DC bus, and this is torque, this is current. So it depends on what you want to read from the drive. Similarly, data out means the data that I'm going to receive from PLC to drive. So the first should be always the control word, the second should be the speed reference. Again, it should be 16-bit, okay. So from here you can use whatever as you require, okay. So this is the basic setup in the communication side, and you can define that how you are going to start the drive. Sorry, not this. Yeah. So you can define the external one command, that is the start command, is from field bus A, which is the one that we defined now, and the speed reference, again you can define it as a field bus A reference 1, okay. So this is the basic setup in the drive to receive the start the drive through profibus. Okay, so now let's jump to the PLC configuration. So as I said, this is my PLC PM8 PM866 and CI84854A. Okay, so I'm going to use this software. This is a compact control builder AC800M software for configuring and programming the PLC. So create a new project. So let's call it ACS880 start. Okay, anything. Okay, so first let's define the controller. So my PLC is PM866, so I replace that and the IP address. So go here and the IP address is 192.168.100.81 and configure the same for the Ethernet one. Okay, so now let's add the profibus master module, that is CI854A. So before doing that, you can see the connector libraries here. This is the hardware libraries. Okay, so if I want to add the profibus master into my hardware tree, then I need to call the hardware files for this. So you can find that here in the hardware. So I have CA854 profibus, just drag and drop here. So now I have this here. So now I can add CA854 here. Okay, so this is done. So I have the CA854 module here. Now I can add my ABB drive here. Okay, again, then I need a hardware file for the ABB drive, which is ACS880. So you can download the GST from ABB website, and the GST file looks like this. FPBA. Okay, so this is the GST file. So you can use DPV1. Inside this you will find this GST files. So you can use any one of this to install the GST, but you need to remember it's not so easy to install the GST like in Schematic Manager or like in AC500 PLCs. It's just a basic installation, but here you need to define, because AC800M works with the hardware files, not directly the GST files. So let's create a new library. So you can give any name. I can call it as ACS880 hardware. You can give any name. Okay, so now you can install the hardware. Okay, so go to the GST files. So I have it FPBA. Okay, so I'm installing the newest one, so I'll use the DPV1, and here you can go for the profibus GS. So this is the GST file. Open that. Okay, so this is the installation tool. So click next. So I'm going to select only the one that I require. So the one that I'm using is PPO2. Okay, so I'll select this one PPO2. Okay, so this means 4 PKW plus 6 PZD means 6 PZD is the 6 inputs or 6 outputs I can send. Okay, so I select this, click next. Okay, so this is important because here is where you define what kind of which format you are going to read and write to the drive. Okay, so you need to define rules like rules here. So I am going to read it as a double integer value, but since I'm going to give speed in negative and positive speed reference from my PLC, and I'm also going to read negative values, so it should be a signed value. So I'll define double integer signed, and also the word also I define as double integer signs. Okay, so after doing this you need to apply the conversion. So it created 20 new channels. Okay, so after doing this you'll get a green tick over here. Okay, which means you are good. So now let's go next, done. Okay, so as I said, now I need to connect this, I need to add this ABB drive here. To do that, again I have to connect my library to this one, so just drag to here. So now your ACS880 hardware is here. Now right click on this, insert unit. Yeah, so this is the ABB hardware. So my profibus address is 3. So select the profibus address, insert. Okay, so I have the drive here. Now I need to add the PPO type. So insert unit, PPO2. Yes. Okay. Okay, so the PPO2 data type, you can see that there are 10 inputs here and 10 outputs here. So as you can see, the PPO type I defined is 4 PKW plus 6 PZD, means the first 4 is used for PKW. PKW is another way of taking data from drive using pointer variables. Okay, but I am going to use the PZD type. So the first 4 you leave it, and we start defining from the 6 PZD, that is from 5 to 10. Okay, similarly when you define the output, that is the control word, you need to define from here. Okay, from 5. Okay, so the hardware part is done. Now let's define the program. So I'll just write program here. I'll just rename this ACS880. Okay, so you can change the language. I'll use the function block diagram to do this, which is very easy to do. So the data that I am going to read from the drive. So as I said, I am going to read all this. So for just giving an example, I will read the status word, speed feedback, and the DC bus voltage. So let's define status word SW. Data type is double integer. Then speed feedback, I'll write speed, again double integer. Then DC bus double integer. Okay. Also I will define the control word. Control word is where you are going to give commands to the drive. Then speed reference. Okay, also double integer. Let's save and close. Okay, now let's connect all this. Okay, so as I said, I'm not going to do in the first 4, I'm doing from here. So I defined here, so I'll call the status word. This is status word. Next should be the speed feedback, then DC bus voltage. Now the control word should be defined here. Okay, let's save and close. Now let's do a download. Okay, we'll do a complete reset. Okay, we'll download. Okay, so we do a complete download. Okay, okay, so now we are online with the program. Okay, so if this profibus was not correct, you will have a red signal over here. So now we don't have a red signal, so we are okay to we are having a healthy communication with the drive, and you also can see what is the value the drive is setting. Okay, so this is my status word, and this is my DC bus voltage. So you can see my DC bus voltage is 571. So I'm getting around that 570, 572. Now so this is something that we are going to send to the drive from PLC. So the first thing, let's decode this status word, because status word is a 16 bits that are sent from the drive. Okay, so let's do the program here. Okay, so in order to understand the status word, you need to download the FPB manual. Okay, so this is basically the 16 bits that is sent from drive to PLC. So first bit is ready for on, ready for run. Okay, the drive is tripped, then off 2, off 3, active or disabled. Okay, so alarm, all these things. Okay, the drive is in remote or local. So these are the data that's sent from drive to PLC. So let's decode that. So to do that, I will use a double integer to BC. Okay, and you can define in edit parameter properties, you can define 16. So what it does is that it like when you connect this status word here, you can decode 16 bits out of it. Okay, so let's define like ready for on. So ready for on, we can define it as bool. Okay, and you can connect here. Okay, so this will be the first bit. Anyway, I just prepared all this. So these are the Okay, so basically these are the bits that as you can see in the manual. All this I just prepared this, so you can connect this. Okay, so just connect all this. Because these all good to understand what is happening in the drive. Okay, so let's save it. Okay, the next is the how the control word that you are going to send. Okay, so I'll define BCD, no, BC2 didn't. Okay, again you need to give it as 16 bits. Now you can connect to your control word. Okay, so from here I'm going to give bits to start up the drive. Okay, so basically the control word is okay. So this is the control word, 16-bit control word. Okay, so as you can see, we'll use this first bit to start the drive, which is the off one command, and off two, like if you have an emergency stop or something like that, you can connect to this, or you can bypass it by keeping it one. Off 3 also should be 1 to continue operation, then operation, and this should be 1. Third bit should be 1, fourth bit should be 1 to enable the RAM generator. Okay, the fifth should be 1. So all this, like you get an idea of this. Okay, seventh bit should be a reset bit, like you can define a bit to reset the drive. Okay, then remote command, it should be true. Okay, so we will all this should be 0. So we do the same thing in the program. So as I said, the first bit should be a start command. Okay, the second, all this according to the manual should be 1. This should be 1. And 8th bit, seventh bit, it start from 0, so it should be 8 in my program. So 8th bit is a reset bit. Okay, and jogging, we are not going to use jogging. Jogging means like giving a sudden command, so I don't need this, so I keep it as 0, and it should be in remote, I keep it as 1. So next bit should be 1. Then rest of the bit from 11, it is all 0, so we keep it 0. Okay, so that is done. Now okay, so now let's define, let's read the speed feedback. Okay, so the speed feedback, so whatever the drive sending in the speed feedback, it's in percentage. Okay, so you need to divide it by 200. Okay, so this is double integer, so you need to define this block as a double integer, 200, and you can feedback 12. Okay, so you get the speed feedback in percentage in this variable. Okay, similarly let's give the speed reference. So speed reference, again, if I'm going to send it in percentage, so I need to multiply by 200, change to double integer. So the speed reference, where's the speed reference? Yeah, so this is the one I'm sending to the drive, and this is where you give the speed reference in percentage. Okay, so I need to multiply it by 200, so that is the normal scaling for the drive, 200. Similarly the DC bus voltage, okay, that we can do later. So now the basic part is done, so I'll save and close. I'll do a download. Okay, so as you can see, this is my status word which I have decoded here. Okay, so the drive is in remote, all these are okay. So once I give the start command, I should get ready run, ready reference, no tripped. Okay, no alarm. Okay, so I'll give a reset first. Now let's give a start command. Yes, so the drive started, you're getting ready for run, ready for reference, and you are at set point because I have not given any speed yet. So let's give a speed, like we'll ask the drive to run at 20%. So you can see the drive is running at 20%. Now I'll run at 80%. So drive start to run at 80%. Now to go to the other direction, you give a negative speed. So you can see the drive go to a negative speed. -90. So it reaches -90. Okay, so now if I give a stop command, the drive ramps down and give a stop command. Okay, so this is how you make a program. It's a simple program, like in UK, I mean, according to your requirement, you can connect like e-stop or whatever you want in this side to control the drive. Okay, so this I just made a simple program to read the value from the drive and how we can give a start command to the drive. So I hope This was clear for everyone, and I preferred FBD because FBD is very easy to do in compact control builder. uh, so thank you for seeing this video. Have a good day.